83.
अच्छा अच्छा अच्छा
না,
আচ্ছা,
83 83
আমরা স্টার্ট করি স্যার, স্টার্ট করে দিই কারণ ইটস অলরেডি 12:45 তো।
Right. Just one thing. I believe they all have some knowledge of programming, isn't it? Some basic programming.
Most of them are third year and fourth year students.
No, for our department they will be having, but since students are from other departments as well, সেইখানটা জানতে চাইছিলাম।
Biotechnology students, you can answer in the chat box.
Okay, chat box. One thing, like last time, let the questions come to you and then you forward it to me. Yeah? And after the talk.
Yes.
Okay, start. শুরু করে দাও।
Okay, sir, you can start, sir.
Okay. Good afternoon to you all. I hope I am audible to you all, at least, if not visible. We will start from where we had left in the last class. In the last class, let's start in a lighter note. Today we all have to have some late lunch, but in the meantime, while you think about the food for your belly, let's see whether I can provide you some food for your thought. And I'm expecting next about an hour or so is going to provide you with sufficient food for thought, and you take it seriously. In the last class, I had tried to impress upon you why everybody, irrespective of his or her area of study, must have some reasonable knowledge of algorithms. Why? Because in every stage of life, family life, social life, academic life, in every stage of life, we are always solving problems, either knowingly or unknowingly. Study of algorithms helps you in developing a mindset to analyze a problem rationally, logically, and analytically. And that's why it is absolutely important. In today's world, it has become even more important. Why? Already we are in an era of artificial intelligence and machine intelligence. And this is going to be more and more part and parcel of our life. I have, throughout my series of lectures, I'll use the word computer and machine interchangeably. By that, if I say machine, it means computer. If I say computer, it means machine. And sometimes I'll use the word robot as well. Then, let us not forget what I had mentioned in the last class. A computer cannot do anything which a human being cannot do. Period. Only a computer does it much faster than a human being, in a large scale, does it accurately, but it cannot do anything which a human being cannot do. Conceptually. And number two, a computer cannot take any decision, cannot take any judgment. They do not have any intelligence at all. Whatever intelligence we have to train the machine. We have to train the machine about intelligence to make judgment. But again, It is the human being behind the machine which is making the machine intelligent. In this background, let us take one example. You get out of your house, you want to cross the road. What do? Look at right, then look at left, and then look at right again, and then you cross the road. Writing this in steps in a piece. If we write in a piece of paper, step 1, look right. Step 2, look left. Step 3, look right again. Step 4, proceed. Now think, you have a machine, call it a robot or whatever, and you want to program it in such a way that it should leave from your room and go to the nearest mall and bring some vegetables for you. It has to cross the road, but it cannot make any judgment. So you have to embed this intelligence to the robot. This sequence of steps is nothing but an algorithm. This sequence of steps is nothing but an algorithm. I'll carry on with this example later on. But now that we have introduced the word algorithm, let us try to explain formally what are the characteristics of an algorithm. And again, in the last class, we have used the word formally. We have defined the word formally. What is meant by formally? Some statement whose interpretation does not depend on the person who is interpreting it. Again, some statement, sequence of statements whose interpretation does not depend on the person who is interpreting it. That's why a natural language, as per se, cannot be directly used for an algorithm. Of course, we'll be using the word English, but in a much more precise way. So what is an algorithm? Algorithm is a collection or a sequence of statements which unambiguously helps in solving a problem. A sequence of steps or statements which unambiguously solves a problem. It will be much clearer if we now try to understand what are the basic characteristics of an algorithm. An algorithm must have 0 or more inputs, must have 1 or more inputs, mind it, outputs, 0 or more inputs, 1 or more outputs, and it must satisfy 3 criteria. Each statement in that set of statements must satisfy 3 criteria: finiteness, definiteness, and effectiveness. I'll explain this. So input, output, finiteness, definiteness, effectiveness. And finally, it must halt. Remember, here is the difference between an algorithm and a code, a program. A program may not halt, but an algorithm must halt. Now let us explain each of these characteristics one at a time. 0 or more inputs. How can we have 0 or more? 0 input. 0 means, now input may be explicit or implicit. For those who have some knowledge of electronics, you may have studied amplifiers and oscillators. Amplifier, of course, we know the input and we know the output. Oscillator, what is the input? Pulse generator, where is the input? Basically, the power supply provides the input there. There is no explicit input. This is, input is there implicit. So that's why we say 0 or more input. If we say problem, find the prime number closest to 1000. I'm not providing any input. It is there in the within the problem statement, like that. So 0 or more input again, but 1 or more output. Quite obvious. If there is 0 output, then we don't need the machine. Why do I need the machine if there is no output? Then finiteness. Listen to me very carefully. Finiteness means each step must be computable in finite amount of time. Each step must be computable in finite amount of time. Why? Because whatever big the computer may be, whatever fast the computer may be, it will take finite amount of time in executing every statement. And since the problem is likely to consist of a large number of statements, even if one statement takes infinitely large number of time, it will not be possible for the computer to come up with the entire solution in finite amount of time. A computer is based on design of philosophy known as finite state machine. I'm not going into that. But for all of us at this stage, we must understand that every step must be executable in finite amount of time. This is finiteness. What is definiteness? Each state must specifically and definitely say what it is supposed to do. What it is supposed to do. There cannot be any confusion, any ambiguity. You cannot say that you may do this, you may do that. That is not allowed. It must be definite. And number 3, effective. What is problem solving? Ultimately, you are supposed to reach your goal. Ultimately, you are supposed to reach your goal. Every step must be effective in reaching your goal. I'm not going into local or global kind of thing, but at every stage, for any problem, it is obvious you have a goal to achieve. Every step must be effective in achieving your goal. Looking at in isolation, sometimes it may appear that why this statement is there, it has got nothing to do with my goal. But if it is a good algorithm, correct algorithm, you easily find that this has definitely some impact on achieving the goal. Typical example, soccer match. Very often you see back pass. Back pass means you are moving backward instead of going to forward. But this is effective. When you want to take a cab or want to take a bus from one stop to reach a destination, sometimes you may move backwards. Say a very common example. For those who are familiar with Calcutta and West Bengal, suppose you are staying in a place place like say Bandel, Chuchura, or whatever, some railway station, and you want to go to Delhi. You come back to Howrah and then take the train, and the train goes over your station. So apparently you are moving backwards, but this is effective ultimately in reaching the goal. And finally, it must be it must converge. Converge is a big word. It must halt. It cannot keep on computing. It must halt. So, summarizing, 0 or more input, 1 or more output, effectiveness, definiteness, completeness, and characteristics to halt. For details, you may consult the book by D.E. Knuth, who is part 1, Art of Computing. Art of Computing. Professor Knuth is like, like Einstein of computer science. He is a faculty of Stanford University. He's quite old now, but he is a genius. So if you want to study further, this is the book to refer to understand what an algorithm means. Now let us get back to our original problem. When I said we have taken the example to cross the road. Now, what I said, look right, look left, look right, and then move again. But if you are in US, it is entirely different, just opposite. Even in Calcutta, if the road is one way, then look right, look left, and then you don't have to look right again. Even in Calcutta, if the road is one way, like Park Street, and the direction changes after 1 o'clock, what do? You adjust accordingly. And finally, whatever be the time, location, etc., if some ambulance or fire brigade comes, then all these become nonsense. They have the highest priority. So you have to be very careful whether some emergency vehicle is coming. It could be some big person, which is very common in unfortunately in our country. But as a human being, you keep all these in your mind. Human being, you keep all these in your mind and make your judgment accordingly. Now, if you want to, just now I told you, and this is going to be a part and parcel of our life. Tomorrow, if you want to have a robot, make him intelligent enough to cross the road and then bring whatever you want to do. The robot cannot make all these judgments. They can do whatever they have been told to do. And that is the reason why each of us must understand algorithm very clearly. Must understand very, very clearly. So, we talk about machine intelligence, artificial intelligence, and all those, but nothing is more than human intelligence. Only thing is, human intelligence has to be injected into the machine. But for that, we have to understand what we want to do. And many things we do with the back of our mind. But computer does not have that capability. So we have. So now, last time what I said, to cross a road, look right, look left, and then look right, and then again. Now we have to enlarge it further. If you are in India, if the road is not is both ways, Even if it's a road is both ways, from which way the things are coming. So all these ifs are coming in. And remember, definition of algorithm, every step has to be definite. You cannot say you can do this or that. You have to be very specific. You can say, yes, if this is it, do this. Otherwise, do this. But no ambiguity. Just such a simple problem. Just see how the algorithm expands. Now, think a bit further. What do you do personally? If you feel there is a chance of rain, you will carry an umbrella with you. So tell the robot that if there is a chance of rain, carry an umbrella. So whatever you are doing, the crux of the problem is nothing cannot be left implicit. And you have to take all the possibilities in account. Or you can say that this is the domain where my computer is going to work. You may say that, okay, my robo is meant for India only. It won't work in US. Fine. So we'll get back to the computing problems, but later on. I just wanted to impress upon you the importance of designing algorithms for everyday life. Think of, you are in, you want to, you cook every day. Somebody cooks in your house every day. You can write an algorithm about cooking. You have to prepare biryani, buy this, buy that, add this, add that. कौन सा पहले आएगा, कौन बाद में आएगा. All these are algorithms. All these are algorithms. Even then, we cannot cook like our mothers or grandmothers. Why? Because beyond that, they have something in their head which we just cannot copy paste. Okay? So what is the lesson we have learned? This algorithm will be a sequence of steps. We understand that. What kind of steps? It can have 3 kinds of steps: sequence, condition, and iteration. Move right, move left, go ahead, sequence of steps. Sequence. Condition: if this, do this, else do this. Condition. Iteration: do the same, repeat the same thing 10 times. In the example of our road crossing, repeat the process whenever you want to cross the road. I've told you once. I will not tell you again and again. Repeat the process. So, sequence, condition, iteration. Whatever complex the algorithm may be, complexity is a different connotation. I'm not going into this. This can definitely be developed with the help of these 3 constructs only: sequence, iteration, and condition. Nothing more, nothing less. When you write a program, for those who are familiar with coding, they also know this, that programming is nothing but executable version of an algorithm. Executable version of an algorithm. By the by, somebody in the last class was asking about pseudocode. Pseudocode is basically the program written in such a manner that everyone understands. And when you write an algorithm, you can write in the format of pseudocode also. But be very careful, be very careful. One basic philosophy of software engineering is design should be independent of implementation. That means anyone, even without hard knowledge of computer science, should be able to understand the design. So when you write an algorithm, write it in, of course, subject to the satisfaction of those parameters, write it in such a way that the domain expert understands it thoroughly. This is very important. More than 80% of our software failure, are because of lack of understanding the requirements, lack of understanding the feasibility. And nowadays, I told you in the last class, most of the computer applications are in social science, life science, medical science. It's not like basic sciences, physics, chemistry, we used to have a couple of decades back. So physical science, yes, they are very hard in the sense P equal to MF is P equal to MF. We know Boyle's law, Charles' law, all those. Whereas in social science or in medical science, it's very difficult to understand what we want. And a computer scientist, a software engineer, is not expected to be an expert in the domain where he is working. Suppose you are, as a software engineer, you are working for some drug formulation. Of course, you are not supposed to understand much of drug formulation, but you are supposed to understand the algorithms. And when you write the algorithms, the domain experts, but they won't know implementation. So the domain experts must clearly understand what the algorithm means. So I hope after this series of talks on algorithms, I'll take a series on talks on software engineering, where there I will mention all these in details. That maintainability, reusability, adaptability, scalability, all these are very, very important, but that we'll discuss during software engineering classes. Coming back to the algorithms again. Input, output, finiteness, definiteness, effectiveness, and using only 3 types of constructs: sequence, condition, iteration, and it must halt. Okay. Now let's get down to another aspect. Same example. You don't want to cross the road. You want to take a bus from Karunamui Salt Lake to Howrah station. You go to the bus stand. Wajake, you are sitting or waiting. Some bus will come. Now, many buses may or definitely will come. So first you have to see whether that particular bus goes to Howrah or not. Then you have to understand, that how much time it's expected to take, what is the fare. So you have some optimality in your mind. You want to reach there fast or at minimum cost or whatever. That we'll discuss later. But one thing is clear with this example, that to define your steps, you need to have some data to work with. Isn't it? Unless you have some idea about the timetable of the buses, unless you have some idea about the fare, unless you have some idea about the timings and all those, you cannot proceed. Practically in almost every case, whenever you write an algorithm, you have to work on some data. And the moment you work on data, how the data is organized, that becomes very important. And this, for data organization, there are so many very important facets. I'll try to just introduce in a brief after 5 minutes. So we have data structures, database management systems, data mining, data warehousing, so many things. But basically it's data structures and database management systems. But everybody did not have to be an expert. Everybody did not have to be an expert in all these, other than IT and computer science specialists. But when you drive a car, you need not have to be an expert in engine, but some idea to hona chahiye. Agar kuch hua hai, to how to address it to some extent. When as a social person, we need not have to be a doctor, but in case of fever, at least we should have the idea that usko paracetamol dena padega. So think of an example, and just this data is not enough. Think of a simple issue. In your house, say you may have 100 books. Many of us have 100 books. No, not a big deal. How do you store those books has a huge bearing on how fast you can retrieve the books. Got my point? If I have some data, some information, data and information is a different thing, but okay, some data, and I have stored it. So why I have stored the data? Because lookup, insert, delete, and update. This I can discuss while talking on databases. So lookup, insert, so depending on how I am going to use my data, the algorithms will vary depending on for the same problem. Say university, they have a huge database, fine, but the same database is used by the university authorities, by the students, by examination section. So in one case, my objective could be that irrespective of the query, the time taken by the machine to solve the query must be more or less same. This is one objective. Other objective could be, yes, we can have many queries, but we know that 80% of the queries will be somewhat like this and 20% would be different. Then my objective could be to store the data in such a way that those 80% queries may be solved in a much faster time, and those 20% queries we may take longer time. Since what is an algorithm? Algorithm is supposed to solve the problem. Whose problem? That is my problem. I have defined the problem. And since I have defined the problem, now I know very clearly what the problem is, what I am expected to get. Accordingly, how do I store the data? And based on all these combination, the algorithm works. So that's why generally always you see algorithms and data structure. Why algorithms and data structures? Because of this. Okay. And then even within data structures, data can be used for two purposes. One is in the workspace. I'm talking very loosely for computer science and IT students. I'll take it later on. Some data you have to say, very simple example. You want to add, say, 2 4-digit integers. When you keep on adding, some carry may follow. Carry may flow 18 plus 17. So 8 plus 7, 5, 1 carries forward. But you don't put it anywhere. You put it in your memory, in your head. On the other hand, if you want to add 100 integers, that also you keep somewhere in your piece of paper, and do it there. What is the difference? Again, I said, each step has to be very clearly understood. In the first step, the carry has to be in your memory. In the second stage, it has to be stored in file. That means in the first step, if the power goes, it goes. In the second stage, it is there. It is permanent. So primary memory, secondary memory, computer organization, that's again a different stage altogether. So all these data structure, how it is stored, algorithms, all these in a combined together helps you solving a problem. But algorithm is the key. Algorithm is the key. Developing the mindset, just like today, even for old persons like me, we use Amazon, Google, and all those to place our order. You can easily see when you go to a market, see all those same rice, 10 varieties, 5 shops, look at them. And then you see, okay, I take this, I take that, take one, refund one. Whereas when you place in Amazon, again, you search everything, but everything has to be done specifically, definitely, without any ambiguity. For today's class, I have another section I thought, because this is a broad perspective introduction to algorithm with formal introduction to algorithm. I hope students, you will remember this forever. Next step is, in the last class, I have introduced the word system, model. Computer is a system. So what are the components of a computer? Input, output, processing unit, and feedback. Again, input, output, processing unit, and feedback. Whatever generation, however big the computer is, they are very sophisticated, faster, infinite memory, and all those. So IO, memory, IO, the processing unit, and feedback, input, output. Some devices may serve as both input and output. Some are input devices, some are output devices. And of course, the bus, that is the networking, which connects all those. Out of these several components, and of course, there is a memory. Any application, we use memory. Out of these, which one is the fastest? Of course, the processor. Which one is the slowest? Input output device in units. So IO is the slowest and processor is the fastest. Which is most expensive? Again, the processor is the most expensive part. Now think of an example of, say, you are going somewhere together, 10 friends or 5 friends going together, but you want to move together. Everyone has its own space or speed. Who dictates the speed of the group? The slowest person in the group dictates the speed of the group. Slowest person in the group, that means the speediest person in the group cannot operate in highest efficiency. It is a fact. So now in a computer, when you run a program, when you run a solve a problem, the software is using IO processor and everything. Processor will be least utilized. So when the computer is not being used, it's fine. But when you are, even when you are using the computer, the most expensive part of the computer is being used least at the lowest efficiency. Now think of two different jobs. One is matrix multiplication, multiplicating 20 by 20 matrix. And the other is computing the salary of 10,000 employees. In the first case, you are using the processor much more. In the second case, you are using the IO much more. If you want to compute the salary of 100 employees, you don't need a computer. You can do it yourself. You want the computer because of large IO. Whereas, even if you want to compute or the inverse of 5 by 5 matrix, you have a problem without it, even though you know how to do it. So some jobs are processor oriented, some jobs are IO oriented. IO oriented jobs are very inefficient so far as the processor is concerned. And the extreme example of IO oriented job is when you're using your laptop for typing a letter. You are hardly using the machine. I remember in our days, sir is here, in our days, I remember the first desktop which came in our department maybe 30 years back, 81, 82. That PC costed 1,20,000 and very less configuration. We were not allowed to use the PC for typing letters. It was strictly prohibited. Over the decade, over the years, now the typewriters have become more expensive than the computers. That's why today we don't mind using the laptop for IO-oriented jobs because the cost has come down to such an extent. But we must remember that by doing this, we are using the machine at a much lower efficiency. That we must remember. So why I am explaining all this to you? Whatever be the kind of problems, whatever be the kind of algorithms, you have to define. You are using the same machine. So in some cases, your algorithms has to entirely concentrate on designing the computing part, how to do it faster in processor-oriented applications. On the other hand, in some cases, what if there's nothing great in designing is an algorithm in a payroll? What is the challenge? There is no challenge. Just a few plus minus addition subtraction. There, of course, you will need to write algorithms, but there the major challenge is in data organization. How do you store the data? How do you retrieve the data? In understanding the problem, understanding the domain. So generally you will see most of the examples given in algorithms are on processor oriented jobs, because that's where the algorithm plays a huge role in bringing down the computation time. On the other hand, in IO oriented jobs, I/O-oriented applications, it's the data organization which plays a much bigger role in an understanding of the problem. Of course, a much bigger role in getting the job done very, very efficiently. That also, while writing an algorithm, we also have to keep that in mind. And finally, another aspect, since I think we should cover the entire spectrum so far as the notion of algorithm is concerned today. Another aspect, let me introduce today itself. Again, I like to give real life examples. Suppose two friends, you go to a railway reservation counter to buy a ticket. What do you do generally? Both of you are in two different queues. And finally, whosoever comes first, you join him. This is parallel computing, parallel processing. Suppose you want to add A plus B plus C plus D. How many additions and steps are required? 3 additions. A plus B, then add C, then add D. If I can do it parallelly, A plus B I do and C plus D, these two I do together by 2 processes and then add that result. So instead of 3 steps, I can do it in 2 steps. Just brief introduction of parallel computing. Other example is, again, real life example. Suppose 4 friends want to go for a picnic from 4 different places and they want to meet a particular place. So they can go on their own and join at some place together. That is distributed computing, where synchronization is a huge issue. For our series of talks here, we will not consider parallel computing and distributed computing. We will not consider that in our case. If having given opportunity, we can take it later on. So before studying any subject, first of all, we must know why we are studying it, what is the necessity, and then we must also know what is the domain within which we are studying. What is the domain within which we are studying? Physics is covered from class 7 to PhD level. And after that, also, many big physicists, they say that we have not learned anything of physics. So whenever we are studying a subject, these 2 things are very important. Why we are studying it, what is the necessity, and number 2, what is the domain within which my study is concentrated. What is the domain within which my study is concentrated? Where algorithms, of course, very much exist for parallel and distributed computing also. But here we are not considering parallel and distributed computing. We are considering only an environment where we have a single processor. We have a single processor. And here I'm talking about, and since I'm mapping social life examples with computing, this I wanted to make it very clear. And it would be proper to reiterate what I had told in the last class once again. Moving for many decades, computers concentrated on solving pure scientific problems. And pure scientific problem means what? P equal to mf. There cannot be any change. Only we need an Einstein to change that. Charles' law, Boyle's law, Kirchhoff's law, Ohm's law. So all those are very well structured, defined to the extent if we fire a rocket from Earth's coast. For next 2 years, up to every nanosecond, we know their trajectory, because it's a very well-structured domain where the scientists used to work. The moment we switch over to life science, I have given that example last class also, but it's very important here. Medical science, we go to medical science, a medical doctor, we have a fever. Doctor says it's fine. You take paracetamol, and then in 5 days, it will be over. Can you ask whether it is 5 days or 5 days, 3 hours, 5 days, 10 hours? Can the doctor say, draw a curve, how the temperature will come down? Unlike in physical examples, I have a particle, I give a force. What is the trajectory? You can define with 100% accuracy. Here I have fever. I have given you medicine. Can you say the curve, draw the curve of temperature versus time? The doctor will say that it worked for 1 million patients. So it is expected to work for you. And at the same time, he will say that every patient is different. Come to social example, social life example. In pure science, we have commutative, associative, transitive, all these laws. If X greater than Y, Y greater than Z, X is greater than Z. No question asked. In social life, if X loves Y, Y loves Z, can you say X loves Z? Problem. Can you say yes? Problem. Can you say no? Problem. Even if it's yes, it may depend on the context. Remember, with all these AI and machine learning, we are moving faster to address all such problems. All such problems. And these problems, pure scientists are not accustomed to handle. They can handle, pure scientists, I mean computer scientists. They have not been told to handle. They have not been studied, not told. They have not been studied. So, what is that? You have to write an algorithm in such a way that for a problem which is inherently full of ambiguity, how to write it in such a way that finally there is no ambiguity. Because if there is ambiguity, you cannot implement this in a computer. And herein lies the challenge of writing algorithms. So far, algorithms has been just like a proprietary subject of computer science. In fact, I am teaching computer science for maybe 30 years. But there, from class 1, for the first class, we used to study complexity, high-flying mathematics, and all those. Yes, those are required. I'm not saying those are not required. But now, the algorithm has to be looked from a different perspective. Look from a different perspective, because previously this high-end computing power was not available. Computing time was so important. Today also it is very important. Probably next class we'll share with you some examples where it can be proved that you cannot do it in a polynomial time. But what we have not thought of, even say 5 years back, we have to think very seriously that, and unfortunately, in our country, we take so long gestation period to change our syllabus. That is the problem. The problem, suppose you have a problem of a biology student, but she has not studied algorithms. And study means, again, the change in mindset. I'm not just saying reading a few books, changing the mindset. Unless you study, you cannot change that. So the and that's why I am impressing again and again to live a satisfactory social life. Now it is we live in a global village. Today we are in India, tomorrow we may be in Germany, tomorrow we may be in the US, and all those. It's a global village. So unless we change our mindset accordingly, we will be in deep trouble. Think of that. Many of you must have seen that ये है ना, वो जो Amazon का Alexa, why don't you switch off the light? Why don't you switch off the fan? Why don't you listen to music? But you cannot say, the Alexa, please switch off the light or switch off the fan. You may switch off the light, that it cannot work. It has to be clearly trained. Machine intelligence, artificial intelligence, all these are big words, but I wanted to demystify this. So I think we had some fruitful discussions. And again, before concluding, I would like to share with you one of the allegations I keep on getting from my students for last 30 years. They keep on saying, sir, what are the references? I said, what I said is reference. I do not maintain any notes. I do not keep any references. Of course, I have some references in my back of my mind. Then I can give you 10 books. Each book could be 500 pages. So they say, sir, the problem is when we were listening to you, we could understand everything. After one day, I thought that I could not understand anything. I said that then there's a big problem because I don't remember what I have told you. Only thing I remember, what I have told, I do believe is very important for you to be successful in your life. So I would request to all my students, think and think what I said and why I said. And finally, generally, I do not like copying from my book in my note and copying my note in the blackboard. Generally, I try to cover only those as a supplement to the book. So while you are attending my classes, please read the books very, very carefully. I am there to help you out. If you have any questions from the book, but it is very difficult. I know the way I have given the talk today, it's difficult, but I hope you have understood everything. And I thought at least not everything, at least 80% of what I said, and I could provide you some food for thought. Now you can have food for your belly. I think that's all today, sir. Thank you. Questions? Any questions? Or you can send it to Samdatta or whoever is coordinating. And
yes, sir.
Yes, but first,
Sir, we have question from Saptarishi Patra.
Sorry.
Yes, sir.
Name and branch.
So we have questions from Saptarishi Patra.
Yes. Which department? Which
so, we are allowing him. Saptarishi Patra, please unmute your mic. And first you tell from which department you are, from which stream. Yes, Saptarishi Patra, please.
Yes, Saptasi.
Yes, sir. Hello.
Yes.
Sir, I'm in MC department. I'm from MC department. So, sir, I have a question regarding
which subject you had in your BSc?
BCA.
BCA. Okay, fine. What is the question?
So, sir, I have a question regarding DSA. Sir, how to trade between time complexity and space complexity? How can I use space complexity to reduce time complexity?
I have not used the word, introduced the word time complexity or space complexity as yet.
Okay.
No. One thing, again, this is a big problem. Of course, we'll introduce this. I keep on telling my students again and again, life is very simple. Don't make it complex. Generally, we make life complex and then say that, life is so complex. I've seen students while studying in class 9, they feel pride in completing the textbook of class 10. But you ask him a question of class 9, he cannot answer. So I keep on impressing upon again and again, try to understand the basics. Okay, you have asked a very valid question, but time complexity I have not introduced as yet. No, time complexity, space complexity, all these will introduce in due course of time. Okay, thank you. Next.
From students and participants, if you have any query related to the project session, then please raise your hand, or you can put your question in the chat box. Dear students and participants, if you have any query related to today's topic, what sir has explained today, please raise your hand or please put your question in the chat box. So probably there is no question because they are just grabbing up the knowledge.
Right. They're feeling hungry. Yes. Okay.